Good morning students, friends. Today we are going to see the basic concepts of probability under the topic statistics. The elementary probability theory was first developed by Pascal, a French mathematician, and the details are given below. Now let us go to the basic ideas of probability. What is meant by probability? So probability is a theory of statistics which involves certainty, then impossibility and uncertainty. So what is meant by certainty? Suppose for example, if you are saying sun rises in the east, it is a certain event or a sure event. So either today or tomorrow or after 10 years also, the sun is going to rise in the east. It is going to be a sure event. Suppose when you take sun rises in the west, it is never be possible. It is going to be impossible event. Then what is the chances that today morning I would take either tea or coffee after my breakfast? So we don't know, either I can take a tea or I can take a coffee. So it is an uncertainty. We are going to predict either this or that. Maybe sometime I don't take coffee also. So now you understand probability is a concept which involves certainty, impossibility and uncertainty. Okay. Let us going to see what is meant by an experiment. So experiment is a attempt, just it is an attempt we are going to make and we are going to get some result for the attempt. For example, we are trying an experiment in a lab, either in physics or chemistry, or we are making some clay, toys from clay, whatever it might be. That is the first we are doing an attempt. From the attempt we are going to get a result. It is called as experiment. So here experiment is classified into two types. One is deterministic, the second one is non-deterministic. So we are going to see what is meant by deterministic as well as non-deterministic. If I say experiment is a deterministic, I know the outcome 100%. What is my outcome? It is going to be predicted under identical condition. For example, if I take an acid base and I titrate, always I will get a salt and water. These things you have studied in your 10th standard. Okay, you take any acid, HCl, any base, NaOH, something like this. If you titrate, you will get a salt and water. So whomever do this experiment, they will get the same output. Now let us go for non-deterministic experiment. People sometimes they call this as random experiment. Sorry. So what is meant by a random experiment? Suppose when you take a coin, when you toss it, I know either I will get a head or I will get a tail. But the problem, I don't know what I get. I know what is the possible outcomes, all the possible outcomes. But I don't know what I will get at the current moment. Similarly, if I take a die, so the die has 6 sides. It has 1, 2, 3, 4, 5 and 6. So whomever they throw a die once, suppose you are throwing a die once, you know either you are going to get 1, 2, 3, 4, 5 or 6. You know the outcome, output. But the problem, you don't know when I throw a die, what is my output. You can predict, you can bet it. Sir, 3 will come, 5 will come, 6 will come. But no one can say the exact answer when you throw a die. Once it stopped, I can see the output like 6 or 5 or 7. So that is called as a random experiment. The same thing, you take a card, deck of cards. You can draw any card. The pack of card contains 52 cards. I know one of them will come out of 52, but I don't know which card I am going to get. Either it may be a ace spade or a heart in queen or a king or any number with different suits. So now let us come back to what is meant by a random experiment. So an experiment is said to be a random experiment or non-deterministic. As I said, all the possible outcomes are known in advance. For example, if you toss a coin, you know either I am going to get head or tail. Similarly, if you take a dice, I know my outputs are going to be either 1, 2, 3 up to 6. But the problem is, when I do the event, when I throw a die or a toss a coin, I don't know what is the current output. So all the possible outcomes are known, but each outcome is not possible to predict in advance. That means the outcome which I am doing when I make an experiment, I cannot predict the current outcome. It can be repeated any number of times. For example, you can throw the die 1000 times, you can toss the coin 10,000 times, it doesn't matter. You cannot predict the current value. So then it is known as a random experiment. Now you understand the difference between deterministic experiment or non-deterministic experiment. In random experiment, you know all the possible outcomes, but you don't know what is the current outcomes. Let us go for the concepts. Trial. What is meant by trial? So performance of a random experiment is called a trial. Okay. So when you throw a coin or when you throw a die, first time it is a trial. If you throw a die 5 times, so each time you are throwing is called as a trial. So when you throw a die, you are going to get a number 5 or 6 or 3 or 2, then it is called as an outcome. The result of a trial is called as outcome. So now you take a die. How many sides were there for the die, guys? Oh, 6 sides, right? Or 6 faces, people say. So now let us see. These are all the 6 faces. So I can put in a set 1, 2, 3, 4, 5, 6. These are all my faces. So I am going to get output 1 among this. When I throw a die, either I will get a 2 or 5 or 1, 6, whatever it might be. So let us go to the concept of sample space. What is meant by a sample space? Now you see, if I throw a die, how many times I throw doesn't matter, but either I will get 1, 2, 3, 4, 5 or 6. So there is no other possibility other than this. When you throw a die, you will never get a 7. This is an error. This is not possible. Or you never get 25. This is not possible. So all the possible outcomes are 1 to 6. So I am going to name this collection as capital S. What is capital S is called as sample space. So what is meant by sample space? The collection of all the possible outcomes is called as sample space. Now you can see the definition. Now you see, rolling a die is a trial because you are rolling 1 time. It is a trial and the sample space is 1 to 6. Okay, next what we are going to do, here my sample space is S. It contains how many elements? 1, 2, 3, 4, 5, 6 elements. So now to count to the number of elements in S, we are going to define as n of S. People say this as cardinality. Cardinality of the sample space S, I am going to represent it as n of S. Okay, so for one die it is going to be 6. Now if you take 2 dice, what are you going to do? So let us consider like this, die 1, and I am going to fix die 2. So when I have die 1, I have 6 possibilities here. If I get die 1 1, I am going to get 1 2 3 4 5 6 here. So I can write 1 comma 1, 1 comma 2, 1 comma 3, etc. Let us see this one by one. So first die I am fixing 1. So my output is 1 to 6. Then similarly I can fix 2 as my outcome in second die. I am just writing all the possible outcomes. Similarly, if I fix 3, 4, 5 and 6. So that means if I throw 2 dice together, okay, I can have one possibility with 6 different combinations. So I have 6 into 6, 36 combination. So the cardinality of 2 dice is going to be 36. So now you can guess, student, this might be very helpful to find the sample spaces in probability in the exam point of view. If you have 1 die, then your NFS is 6. If you have 2 die, your NFS is 36. If you have 3 die, your NFS is simply 6 cube. So now what you can do, you can replace like this. So 636 you can view like this, 6 power 1, 6 square. So if you have n dice, my sample space is going to be 6 power n. That's the best and simple idea to remember about the sample space. Similarly, so in probability, most probably what we are going to see, we are going to deal with dice, we are going to deal with coin, and then deck of cards and some combinations we are going to deal. So these 3 we are going to deal, and these combinations, for example, 7 men and 10 women are working in a company. What is the probability in different combination? 2 women, 5 guys. So those kind of combinations are problem 4. So we have only 1, 2, 3 and 4 kinds of problems. So this is also the limitation for probability, because we know when you throw a coin, we can find a sample space. When you throw dice, we can find a sample space. In real life problem, there are many different uncertain problems where we cannot find a sample space. Then it is tough to use the probability directly, and we have to go for further process. Okay, so we are in elementary level, so we don't worry about it. We are going to see all these 4 kinds of problems. Okay guys, let us go for another example. Suppose when you toss a coin, it is a trial, and the sample spaces, either I am going to get a tail or I am going to get a head, or you can write like this also, both are same. So the outcomes are going to be head and tail. So now the sample space for one coin is going to be 2. Let us see for 2 coins guys. So if you have 2 coins, I'll get head head, head tail, tail head, finally tail tail. Here it is very important, this head tail and tail head are different, because this head is coming from coin 1 and this head tail is coming from coin 2. Here the tail is coming from coin 1 and the head is coming from coin 2. So it is very important, you have to take all the combinations. So the sample space for 2 coins are this. So my cardinality is 4. If you take 3 coins, now you have to fix like this, 2 heads, then head, 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 tail, and different combinations you have to write, head, tail, head, then tail, head, head. So now I fix 2 heads. Second, I'll fix 1 head and tail. Then I can get all the possible outcomes. So N of S cardinality for 2 coins is 2 square, I can write it as 4, and cardinality for 3 coins is 8, that I can predict is 2 power 3. Now you can guess my point what I am going to say. The sample space for n coins is 2 power n. Hope you understand. Next, the important thing, as I said, we deal with dice first, then coins. Now we are going to deal with the deck of cards. So you people aware of cards. So the total number of playing cards is going to be 52 here. Okay, we have 52 cards in a deck. We don't bother about the jokers. So we have 4 suits. What are all the suits? Heart-in, diamond, spade and claver. Okay, so we have 4 suits. So 52 cards divided by 4, we can have 13 cards in a suit. So we have 4 suits. Number of colors, heart-in and diamond is going to be the red. The other 2 are going to be the black. So each suit, as I said, 13 cards will be there. So 13 into 4. So we'll have 26, 26, 2 colors. It is going to be 52 total. Okay. So in this card we have ace, king, ace, queen. Sometimes people say knave or jack cards. So we have 4 cards here. Okay, so in each color we have 4 cards. So we are going to have totally 16 cards in the deck. So face cards. What are the face cards? King, queen and jack are the face cards. So the number of face cards is 3 for each color. So we have, for each suit we have 4 suits. So 3 4s are 12. So the number of face cards are 12. So as usual, the total number of playing cards is, when you count whatever the possibilities, it is going to be 52. Okay. Sometimes people say honor cards or honor cards. So honor cards are nothing but the same: ace, king, queen and knave. So each suit we have 4. 4 4s are 16. So we are going to play game with this problems. So next we are going to see what is meant by event. Yeah, let us see. In the sample space, as I said, when you throw a die, we are going to have all the possibilities 1 to 6. So now what is meant by event? So if I take just 1 or just 5, these are all my 2 favorable thing. I want either 1 or 5 when I throw a dice. Then this subset I am going to take it as capital A. I like 1 and 5. So 1 and 5 is going to be my event, and it is always a subset of the sample space. It may be all the data, 1 to 5, 1 to 6, okay, or any combination. You can take 3, 4, then you can take 1, 2, 3, etc. So now event are divided into 2 types. One is called as simple event, the other one is compound event. Let us see what is meant by a simple event. So rolling a die is a trial, and getting 2 is an event. People say event, sometimes they will say simple event, both are same. So what is meant by a simple event? When you throw a die, at most I am going to get either any one of the number. Okay. So simple event is the very basic possible outcome of a random experiment. When you throw a dice once, okay, you are going to get one number. So that is going to be my simple event. Okay. So what are all the types of events are there? So we are going to see one by one. So these are all the very important types of events we are going to see for our examination point of view. Okay, let us go one by one. So what is mean by sure event? I said a event which is going to happen 100% without any change. Sun rises in the east. It will never change. It is going to be a sure event. So we can give this example normally. How to say this as mathematically? So if I say, if I throw a die, I will get an output 1 to 6. There is no chance of getting 7 or 8 or 9 when I throw a die. So this is a very tricky thing. If somebody asks you, okay, please throw a die, what is the output? If you say 1, if you say 5, it is not sure even, because if you say 1, you may get the output 5. If you say 5, you may get the output 2 or 3 or something. So sometimes you may get 5. So what is the tricky answer to say? If somebody is asking you, when you throw a die, what will you get? When you throw a die, you will get any number between 1 to 6. If you say like this is the sure event. Can you understand, guys? So if I say when I throw a die, no other chance. Either you will get from 1 to 6 means you are exhausting all these things. So now you understand what is meant by a sure event. If you say event with total sample space, it is called as sure event, because it will not go beyond it. You will not get 8, you will not get 25, you will not get 300. When you throw a die, what are you going to get? If I say, you will get between 1 to 6, done. Then it is called as a sure event. The next one is called impossible event. As I said, what is the impossible event? When you throw a die, if I say, what is the problem? What is the data? I'll get 25. You will never get 25. So it is going to be null. Okay, it is going to be empty. How many times you throw the die doesn't matter, right? You're going to get only empty. This is called as impossible event. Okay, so here I give some very basic example using power set. You people may read power set in your school days. If you take 4 elements, so power set is defined by P of S. You have to write all the possible combinations from null set and singleton set 1, 2, 3, 4, etc. And all combinations you can write. And here we are just writing combination. So 1, 2 is equal to 2, 1. We are not going to bother about the arrangements. Let us see. In this power set, we are going to say this 5 is going to be your impossible event because it is empty. So as I said, simple event. What is meant by simple event? The basic unit of this. Suppose if you say power set is your sample space, the basic units are 1, 2, 3 and 4. They are going to be called as simple or elementary events. And if you take the whole set 1, 2, 3, 4, then it is going to be the sample space. Yes. Now if you take an event like this 2, 4, 3, 4, 2, 3, they are not simple. It has two possibilities. Either you will get 2, 3 or 2 or 3, something like this. Then this is going to be a compound event. So we are going to see this in detail for coming classes. Okay. Now complementary event. What is meant by complementary event? Suppose you are going for a multiplex theater to watch a movie. There are 3 movies running at the time 10 a.m. For example, let us take. So what can I do? At a time I can watch either A or B or C. So now you see, I can suppose I'm going to A. So I will watch the movie A, and what I miss? I will miss the movie B and C. Hold together it is my sample space. So my sample space, I have the possibility either I will go to movie A, B or C. If I see movie A, and what is the remaining thing? The remaining thing, I am going to miss the movie B as well as the movie C. Okay, so A I am going to watch and I am going to miss B and C. This is my sample space. Now I hope you got the idea what is meant by a complementary event. If there is a event A and there will be always not A. If I watch a movie A and I am going to miss some other movies B, C, etc. in the sample space. So for the event A, always there is another event A bar. That means if you watch A, there is always you miss B and C. You miss something. You take something, you miss something. So how can I define a complementary in the whole sample space? This is my A and the remaining data which I miss, it is called as not A. This not A is going to be named as complementary event, guys. Okay, so A bar is also called as complementary to A. It is also called as not A. Now this is the picture representing A is my event from the sample space. So in the sample space I have three movies A, B, C. Okay, if I watch A, I am going to miss this B and C. So A is my movie and A complement is going to be my B and C, guys. So complement can be represented sometimes A complement, A dash, A bar. It depends on book to book. All the notations are same. Next we are going to see mutually exclusive event or mutually disjoint event. By the name itself you can understand what is meant by mutually exclusive. Okay, you can just see the occurrence of one event will stop the occurrence of other event. Now you take a coin. So if I get head, I will not get tail. Similarly, if I get tail, I will never get head at that time. So the occurrence of head will prevent tail. Similarly, the occurrence of tail will prevent the head. So now if you say two events are mutually exclusive, the occurrence of one event will stop the occurrence of other event. If you say 5 events, then occurrence of, you can take this die. So you will have a sample space 1 to 6. So if you throw a die, suppose you are getting 2, that means if you get 2, then it will stop the possibility of occurring 1, 3, 5, 4 and 6. So the occurrence of one event stop all the occurrence of other events simultaneously, then it is called as mutually exclusive event. So the simple example is getting head and tail in a coin. When you throw or when you toss, these are all mutually exclusive. If you get head, you will not get tail. If you get tail, you will not get head at a simultaneously. Now you understand, guys. So that means if I have an event A, if I have an event B, if I say they are mutually exclusive, how I can justify or how I can represent in terms of mathematics? There is no common element between A and B. So if there is no common element, their intersection is null. Do you remember, guys? Disjoint sets, overlapping sets. If there is no common element between two sets, then they are disjoint. If something is there, then they are overlapping. Since I see occurrence of A will stop the occurrence of B, that means A and B does not have any common element. So their intersection is going to be empty. So that is the concept of mutually exclusive events. As I said, if you take a die, let me explain. my sample space is going to be 1 to 6. Okay, a guy is betting on odd number. So 1, 3, 5. A guy is betting even number. Okay, 2, 4, 6. Now you see the event odd number and even number are going to be mutually exclusive, right? If you get 2, you will never get any of the elements from here. If you get 1, you will never get elements from here. So I am going to take 2 events, getting odd number and getting even number. Then I can say these 2 events are mutually exclusive because nothing common between them. Similar example is given, not only odd even, you can take 1, 2, 3, 4, 5, 6. Then this A and B are going to be again mutually exclusive. Hope you got my point, guys. Now it is very important to know about exhaustive event. In mathematics, exhaustive is different. In English point of view, like language point of view, when you speak about exhaustive event, you say, I'm totally exhausted. That means what? I'm totally tired. I cannot do anything. Okay, like you can say like this. I'm totally exhausted means, suppose for example, you can do 10 jobs a day. So if all the 10 jobs are given to you, if you finish, you cannot go for 11th job. That time you shout like this, I'm totally exhausted. That means there is no other possible items you can do. So now mathematics probability, what is meant by exhaustive event? All the possible outcomes of an experiment is called as exhaustive. So again and again and again I'm going to explain with dice because this one example make you to get clear about all the ideas. Now guys, I'm going to take A set as 1, 2. The same odd number I'm going to take. So I'm going to have 1, 3, 5. And the even number I'm going to take 2, 4 and 6. Now let us see, when you speak about mutually exclusive, you do intersection. When you speak about exhaustive, you do union. So let us see what we are going to do. So now I am taking A union B. Okay, here we don't have B, so I am going to just take A union O. Okay, I am going to take A union O. Okay, so what is the common elements between these two? 1, 2, 3 and 5. Now I cannot say this is mutually exhaustive. What is the reason? Because in my original sample space I have 6 elements. Now here I see that 4 is missing and 6 is missing. So I cannot say A and O are mutually exhaustive events because it is not covering the whole set. But if I take O and E, O union E, I will get the original sample space 1, 2, 3, 4, 5 and 6. So I can say here, what I can say, odd number union even number is going to be my sample space. But if you say A is some 1, 2, so A union E is not equal to S, A union O is not equal to S. So these A and E, A and O are not exhaustive event, but odd number and even number union is going to be exhaustive because it is covering the whole sample space. The other beauty of this odd and even, this is also mutually exclusive. There is no common element between them, as well as it is covering the sample space. So you can remember, set of all odd elements and even elements in the die is going to be both mutually exclusive as well as exhaustive. Is it clear? So exhaustive, it will not stop only by 2 events. You have A1, A2, A3, etc. 10 events. So if you union all this event, at the end, if you get sample space, then you can say these events are exhaustive. Equally likely. It is very important in probability, it should be equally likely, right? When you throw a coin, you should have head and tail. Suppose if I have a coin which both sides head, this is very bad, okay? You will never get tie. This is cheating. This cannot be equally likely. Now you understand what is meant by equally likely. If we say two or more events are happening, then it should have equal number of chances for every data. Okay, for example, see this die. It has 6 sides. Each side will have one number. So getting 6 or 5 or 4 have a equal chances. You see, the die is splitted and it is given. The second die is with colors. You see, there are 2 pink colors in this die. Then this is cheating, right? Pink color have a probability to occurrence 2 times it will occur. There is more probability. And for the blue, green, yellow and light red, it has 1 chances. This is not equally likely. So equally likely means it should be splitted equally for n number of events. Yeah, I hope you understand, students. The next we are going to see about independent events. So what is mean? If there is an event which is called independent, we can say there is some event dependent. So if you say 2 or more events are independent, then occurrence of one event does not affect the occurrence of other. Then it is called as independent event. Okay, so I will explain you. Suppose I have a sample space where I am throwing coin. Okay, so for this coin I have head and tail, and I am also throwing a die. I have a 1 to 6. So now you see, if I throw a coin, I will get head or tail. Simultaneously, if I throw a die, I will get any number. But occurring 6 and occurring tail, they have no way connected. You see, occurring tail or head, it depends on the coin. Occurring number 6, it has some probability with die. But occurrence of 6 will never affect the occurrence of tail or head in the coin. Similarly, occurrence of tail will never affect the occurrence of 6 in the die. So these 2 events are independent events. If occurrence of one event is affecting the occurrence of other event. For example, if you play a game, video game, if you say you are in level 7, that means the meaning you already clear level 1, 2, 3 up to 6. So if you failed in level 6, you cannot go for level 7. So these event 1, 2, 3, 4, 5, 6, they are depend on each other. If you want to go reach level 7, then you have to clear all this level 6. Okay. So the occurrence of one event or non-occurrence of the event, it is going to affect the occurrence of the other events in the trial, then it is called as dependent events. Now I will give a complete idea and explanation about whatever the data we discuss. If 2 sets you see A and B, they are no way connected. So A and B are mutually exclusive. There is nothing common between them. But you see there are some data which is missing. So we cannot say this is exhaustive. It is simply mutually exclusive. But when you come to second picture, it covers the whole sample space. You see, this part is A and this part is B. So this is mutually exclusive as well as exhaustive. Then coming to the third picture, there is some common element between A and B. So it cannot be mutually exclusive, it is mutually inclusive. Here you see A is like this. Okay, so I can just highlight this. Okay, this is my A. Then I will say this is my A and B is like this. So you see here, this is my B. So there is something overlapping between A and B. So this cannot be exclusive. So they are mutually inclusive, as well as it is covering whole sample space. Then they are exhaustive. So these are all the basic ideas before we start probability. Just we are learning. So here we stop the basic ideas before we start probability, guys. Hope you understand. Then in the next session we are going to see the formal definition of probability and how to use this in problems. Thanks for your patience and watching the video. Thank you once again. Goodbye.